If you're just getting started with PCG, this is the video for you. I'm going to go over the very basics of PCG and things that you should know when you're getting started with it. That way, once you watch this video, you'll be able to understand better all the other PCG tutorials that are more advanced and start actually looking into specifics of PCG you want to learn and understand kind of the basics that are being explained no matter where you go, whether it's my own videos or somewhere else. So with that out of the way, let's begin. To get started with PCG, you of course need to enable it by going to Edit Plugins, searching for PCG, turning on the Procedural Content Generation Framework, PCG. This is the base one. Go ahead and hit yes when you check it on. There are other ones that are helpful for this, but we're not going to be doing any of that. That is the more advanced stuff. There are tutorials out there that are more specialized for each individual thing. We're just going over the very basics. But once you have it turned on, go ahead and restart your engine. From there, we can get started with PCG. To create a PCG graph, just right-click, go to PCG, and grab yourself a regular PCG graph. Now, I'm in 5.6, so I have the option of creating a template. We're not going to use anything. We're going to use a basic empty graph for this. I'm going to call it PCG_basics. And before I open it up, I'm going to take it and I'm going to drag it out into the world. Now, something to note here is this is a volume. Inside of this volume, you can have all your PCG, but you can also build outside of it if you so choose. It also, by default, does not come in as 1:1:1 scale. It comes out as 25:25:10. I mention that because if you were to get the actor scale for whatever reason using just this volume, it would be not 1:1:1, so keep that in mind. But I'll go ahead and just put it at origin, and then let's go ahead and open up the graph. So this is the full window here. I'm in 5.6. So we have the main kind of area here where we do all the PCG graphing. On the right here is the detail panel. Below is our attribute information, which we'll get into in a moment. Then we have the option to debug. We have the graph parameters. And here we have the data viewport. I'm not going to go in depth on the 5.6 specific features. I do have a separate video going over all of those, but I will go over things that you should know that are just general across PCG for the basics. So before we create some points, let's talk about what is PCG really, and it is just a point scatterer, as I call it. It takes points and it scatters them around based on your parameters, and then you could do something with those points, usually spawning something with them, whether it's being a mesh or a blueprint, which means if you're wondering, does PCG support X type of plugin or X type of actor, you just need to ask yourself, is it a static mesh or is it part of a blueprint? If either one of those things is true, you can use PCG to just spawn it, and obviously it will then have all the functionality of the blueprint or the static mesh. So it's extremely versatile. But how do you create these points? Well, there's a few different ways. If I go ahead and right click and search for create, down here under spatial, you see create collision data, create points, create point grid, point sphere, spline, and surface from spline. For the very basics here, we'll go ahead and create a points grid. So you get this node, and you get this out with this blue icon. This blue icon means point data. What is point data? For me to explain that, I have to show you also debugging and seeing the attributes. With the node selected, if I press A, you will see this icon right here. And then with it selected in the bottom left corner, you will now see that this attributes has populated now with all of this information. And this is the point information. So every line is a new point. Its positions, its rotation, its scale, its bounds, its colors, its seeds, all the information for all of the points are here. And only points have all of this information by default. Because in PCG, there are things called attributes. And attributes are effectively variables like in blueprints. But attributes are separate from all the rest of the point information. You could have a separate attribute from a separate point, or you could have them all combined. So that's why the blue icon here designates that this is a point information, which means it is guaranteed to have its index, the position, rotation, etc. that you see here. So what is an attribute and how do we use those? Well, as I mentioned, it is just a variable. I can drag out and search for add attribute. Now there's a couple different ones. There's the parameter version, and then there's a math operation. Math add is, as you would think, 5 plus 5. Attribute, and under the parameter, adds the attribute to the whatever it is. You can add an attribute to an attribute. You have multiple attributes together, or you can add attributes to points, which is what we're going to do now. So we're going to say add attribute. If we look here in the detail panel, we are specifying a double value of 0, output target is none. Nothing's going into the attributes. How do we use this now? It brings us to this input right here. This icon here is different than this output blue. This is an attribute icon. In fact, if I open it up, you'll see there's a bunch more of them. Same thing with the create points grid, a bunch of them. And that is an attribute type. So it doesn't take points, it just takes basically the variables. Now, one important thing to note for these attributes, they cannot hold a variable type that itself has multiple things inside of it, sort of like an array or a struct. So you can absolutely assign a random value from an array into an attribute, so that way you have only one of them, but the actual attribute cannot be an entire array of a bunch of different numbers, for example. So something to keep in mind. Now, that doesn't mean you cannot have arrays in PCG. You can. It works slightly differently though, and that goes into slightly more advanced stuff. But the main thing here is on this add attribute, we can specify an attribute ourselves, or here under type, we can specify what it is. So if I go ahead with it selected and press A, and again, get the attribute information, we still see that it has maintained all the point information because it has gone into this in. This in is a wildcard in, which is why it is gray. But it has gone ahead and made sure that it passes through the same type that has gone into it, so that's why the output is blue. And if I scroll all the way to the right, you will see we now have a new double type attribute of a type none. And you can see it's just set to 0. All of this is 0. Now I can name this attribute. So for example, I can tell this to be kittens. And now you can see it is named kittens and every point has 0. I can change the value here. I can say there are 10 kittens and now every point has 10. Now this is all cool, but we're just setting one value on every single point. So let's start going into the next awesome node that is very useful. And that is attribute noise. Attributes, like we discussed, is basically a variable. And attribute noise basically takes a variable, whatever it is, and randomizes it. Now you could overwrite the original attribute that it was, or you can make a new one from it. So let me show you. Alt-click to detach the spline, just a hotkey. So the actual connection is broken. Then I'll drag out and I search for attribute noise. And then we'll plug that in between the two. Again, you'll see this comes in as a random because it does not require point information. It could go ahead and use attributes themselves. And now with this attribute noise, let's take a look. Our input source is at last. Now, at last is very common. You will see that a lot in PCG. All at last is it uses the last information that was right before it, whatever it is. If you were just modifying the density, it will use the density. If you're just modifying the position in the z-axis, it will use the position in the z-axis. Whatever it is, it will use the last thing in there. Sometimes that's all you want. Sometimes you want to specify something. So for example, if I hit this plus button, I can go to point and specify something very specific. So I could use, for example, the density or the bounds minimum or extents as the base of what are we actually going to be randomizing. Now for this, it doesn't really matter what we use specifically if we're setting it. But if you want to, let's say, scale the bounds by a certain amount, then you'll specify the bounds. In our case, I just want a random number. So I can just choose any one of these that is, well, itself a random float. So I can just use density. And you see when I select it, it says now density, and the output target is now at source. That is also a very common thing. At source just goes whatever is in input 1. So you see input source is density. So the output will overwrite density in this case with whatever we're doing here. In this case, we're setting it. We could do a multiply add minimum or maximum, as you see here. But in this case, we're going to overwrite the density with a random value between 0 and 1. So it could be nice to randomize an existing value, or you can write out to a different one. So for example, if we change this output target from at source to just the word random, and with the attribute noise selected, again, I press A, and I scroll to the right, you'll see we now have a random, and here's our value going between 0 and 1 for every single point randomly, as you can see. This has now basically given us a 0 to 1 random value based on the density, which was itself just a float. So now let's say I want to have the kittens actually be a multiplier of that random value. So that means we need to plug something into this attributes. Well, these are points, and we cannot plug points into attributes. But what you can do is convert. So if I drag out of the point information here, and I search for point to attribute, you'll see right here under parameter, point to attribute set, which gets us this conversion. Now, this loses all of the point information and only retains attributes. What do I mean? Well, if I press A on this, you will see all of the point information is gone and we're left with just random. That is the only point of information we have. If I was to just real quick, take this attribute noise and plug another one in between here, and this one I'm gonna call random 2, you will see that this conversion now has random 2 and random, but you'll also notice they're in the same value for both, because every single value, every single noise always comes with a seed, which you can just click and drag and randomize it, and now they have different values. So cool, we now have this attribute. So if we wanted to, we could just take this and plug this in here. But here's the thing. If now we press A on this kittens, you'll see, well, it's just getting the value of random. And we didn't really specify which one we wanted to use here. And the reason it's random is because it is the last one that we attached, which is this. And remember how by default, it'll always do the last thing? Random is the last one we did, so it is using random here. If we want to specify, we can. And this comes to the next useful node, which is, if I drag out of here, delete attributes. And you can see now, again, same kind of wildcard input, but because we plugged in attributes, we're getting attributes out. If I press A on this, you'll see we still have random 2 and random, and we have the option of deleting attributes. For example, we can delete random, and now we're only left with random 2. The other option is if you have a lot of attributes, instead of deleting the selected attributes, you keep only the selected attributes. So for example, I can keep only random or only a random 2. Because let's say we want to actually use random 2 specifically for this kittens. This is a float. We don't really want a float. We want to get whole kittens. I don't really feel like having a partial kitten. So it is an attribute. It is a float value. We can do math on it, which means I can just drag out and search for multiply. And because I'm in 5.6, I can just type in a value here. But if you're in previous versions, all you do is drag out, search for create attribute. And then in this create attribute, you will be able to plug in the value you want and also change the type it is. Because I'm in 5.6, I have the inline option of plugging something in. So let's say I want to multiply it by 10. So the 0 to 1 random will become 0 to 10 random. And by the way, you absolutely can plug this into multiple things at the same time. And then in the multiply node, you can see it's at last. And if I remove this delete attributes and I had both of these plugged in together, I can specify random for the first, random 2 for the second, and the output will be combined random, because again, we've changed it from source, otherwise it'll overwrite the random. And so if I press A on this multiply, there's random 2, there's random, and our combined random is of course the multiplied version of the 2 together. So you can absolutely use multiple attributes. I'll go ahead and go back to the multiply by 10, because that is all we want. And you can see here, our value is now randomized between 0 and 10, but it's still a float. So from here, I can just drag out and search for round, attribute math operation, round, and now press A in here. You can see it is now getting only integers between 0 and 10. And now on this add attribute kittens, if we take this round and plug that into the attributes and press A on the kittens, you will see here it is. Here is the point information and how many kittens that point information has, just like that. So we are now able to take a bit of point information, modify it, get an attribute out of it, modify the attribute, and set it back. It's cool because store the variables on it, but how do we use them then to do something? Well, let's say now we want to move things based on the attribute. Maybe the more kittens there are, the higher up whatever it is going to be in the world. So just like before, I'm going to use an add attribute, but this time I'm going to use just the attribute math version of add, and you'll see we now have an attribute operation. I'm going to plug the add attribute kittens here output into both the input and the output. We're going to make it so the points move up. Now, we haven't been looking at the points up to now. It'll be nice to see what they look like. If I select this add attribute and press D, you'll see this blue icon here. You also, in the world where you drag this out, you will see the point information. Now, it looks like a big solid grid because we are using a point grid, but you can change how the actual debug is displayed. In the detail panel here, you will see debug is turned on at the very bottom here. You can specify extents and the shape it is, as well as a material override. But if you just change from extents to absolute, I can change the absolute value to, let's say, 0.5. And now you'll see that we are now seeing the points at half size. And you can now see that's the actual grid of points that we're working with. So now if we add them, if we move them up, we can see what happens. In our add node, for input source 1, what is actually being modified? Well, we want to modify the position in Z. So we're going to hit the plus icon, go to point position. There's no Z position, there's just position. But we can say position dot Z, which is the axis. For rotation, keep in mind that if you are going to be using this for rotation modifications, it is not XYZ, it is roll, pitch, yaw. So if you were to want to modify a value, let's say by 10 degrees, you want to do rotation dot yaw with a dollar sign in the front. It'll plug everything in automatically here. You just add the dot whatever it is. We're going to be modifying position.z, and I want to specify specifically kittens as our input source too. If I, for whatever reason, mistype one of these, you'll immediately get an error here. And the error just says the attribute property blank from wherever it is does not exist. All that means is you're trying to grab a value that you haven't added to your point information. So all you need to do is just press A on the node before it and just scroll to the right to make sure you're getting the right attribute here. You can see them right here, random2, random kittens. They're also the only ones that don't have the dollar sign. All of these dollar sign attributes here are from the point information. So we'll specify kittens in position Z. And now with it selected, I'll press D and you'll see they're kind of moving up a little bit. Now it's hard to tell because we've only moved them up only so much. And what if we want to modify it dynamically? You can have easily overwritable parameters in PCG. In the bottom left, if I go ahead and select graph parameters, we can add a new parameter here. I'll press the plus button. I'll double click on new property to rename it. I'll call this vertical scale. And I'll just change the default here to be 10, just like we had before. And then all I need to do is right click and search for get vertical scale. And you'll see there's our attribute. And I can plug that into the 10 here. Now, unlike regular blueprint variables, there is no eye icon to make this exposed. It is automatically exposed. You're not able to hide a variable from not being exposed, but that's why you also have the constants that are not variables you can use just as regular numbers. So if you need it to be controlled, make it a parameter. Otherwise, leave it as a regular constant. But now that we have this, how do we use it? Well, in our actual viewport, in the detail panel, with our PCG graph selected, all you need to do is go under your PCG section, open up the PCG component, go to settings, the graph instance, and then instance, and you'll see that is where your graph actually lies. So effectively, if you forget where it is the PCG component, and then open the first thing you can in order. And then eventually get to your graph, and then you'll see the parameter overrides here. If I go ahead and open this, you'll see there's the vertical scale at 10. I can now check this box and have this value changed by setting it to, let's say, 100. And you'll see all the points are now moving a bit more up. We can change it to 1,000, and they're going up even more. And we can have this go up past the bounds of this box all the way into the air, because they are now randomly moving up between 0 and 5,000 in exact increments of integers. But keep in mind, we're debugging here. I press the D key to see the point information. This doesn't actually exist in the world. This is not actual cube spawned. So let's say we actually want to now make use of this. I can drag out of here now and then search for spawn. There are several spawners available in PCG. Spawn actor spawns blueprints. If I go ahead and select it, you'll see it gives an error, but don't worry. Over here in the template actor class, we can specify the type of actor we want to plug in here, and it will spawn whatever that blueprint is. For example, I can search for point and grab ourselves a point light. And now in the world here, there's a bunch of default point lights around, and they're set to stationary as the defaults would be. And you can actually select these and now move them around because they're actors. And you can see here, they're now under a folder and they're all put together. But if I was to select the graph and either move it or click clean up and generate, it'll put that point back where it was. That's cool, you want to do this, but you don't want the default settings on whatever this actor is. That's where this allow template actor editing comes in. For whatever blueprint you choose, turn this on, and you'll see this template actor now on top. You can open it, and you can tweak the default settings on whatever it is. For example, you could change the unit type, you could change the attenuation radius. I can search for color now and change the light color to make it nice and red. And you can see now there's our new lights. They're now all red, and you can see they have the new attenuation radius. You could even override the actual parameters using attributes dynamically, but that goes into more advanced stuff, and I do have other tutorials for this as well. But I wanted to show you that you can spawn anything that is from a plugin or just uses any kind of blueprints. You can even specify that you want it attached to the actual graph instead of a separate folder. And now you can see under the PCG graph itself, here are all our point lights. And don't worry, if I go ahead and detach this, they all get cleared out automatically. Aside from the spawn actor, the other one that's commonly used is the static mesh spawner. As the name suggests, you can spawn static meshes. So here are the mesh entries. We can just add a new entry, open it up, open the descriptor, and we can specify a static mesh in here. Let's say a basic cube. And you can see here, we automatically get the template. So for this static mesh, we can already specify things like the collision, specify block all, for example. And now we have the cubes actually spawning in the world, proper cubes. So this is working real nice. Now it's a little bit boring. You know, it'd be nice if they were actually maybe different scale and different rotation. So let's introduce you to the next very useful node that you're probably going to be using probably more than any other almost, and that is the transform points node. If I drag it out and search for transform points, it's under point operations, transform points. We'll plug that right in between, and now we can modify the point locations however we'd like. We can even give it ranges. So for example, I can specify rotation minimum will be 0, rotation maximum will be 360 degrees in all 3 axes. What we now have is the cubes randomly rotated on all 3 axes on all these points. We can also give it a minimum and maximum scale, so we can have it scale between 1 and 3. And you can see now it's becoming a little more interesting because it's now scaling the cubes as well. And by default, there is uniform scale to be on. If you would go ahead and just disable this, well, now you're getting every individual axis is actually scaling differently. Now, let's say you weren't quite happy with this setup. You kind of want to randomize the scale a bit. Now, you might think, well, that means you need to control the seed specifically for this node. And you don't actually have to. There is a global seed that affects everything. So what we can do is on our PCG graph, down below here, below our vertical scale that we set up, you'll see seed. We can change the seed here to 43. And you'll see this graph has regenerated with a new value. Go 45, 48, whatever you want value-wise, put a new number in, it will randomize all that information. So the rotation's randomized and the transform is randomized. If you did want to randomize only a very specific thing and not the entire thing, you would need to open this up and you will see the seed specifically for this node. And you can plug an attribute into here, and you can create an attribute of a float, plug it in, and then if you modify just that attribute in the overrides, you'll modify just this transform's randomness. Now, another important thing to note here is this recompute seed on this transform point. This is similar to another node that does the same thing, but is an individual node called mutate seed. Mutate seed, you can see, just has a seed option. Just like this recompute seed will use a new seed as well. When you duplicate a point, you're duplicating the seed of the point. Now, this transform points, the randomness that it has chosen here is based on the point's seed. So if you're duplicating a point over and over and over with the same seed, that means that when you rotate them or when you scale them, they will all be the exact same rotation and scale. Anything on this transform point will happen to all of them at the same way. So what a recompute seed does, and what mutate seed basically does, is it re-randomizes all the seeds for all the points. So that way, instead of every point now having the same seed, it puts new seeds on all of them. So they now will once again properly randomize. So this is a nice basic setup of how to just spawn things. What are attributes? How do you modify the points? How do you use them? There's another node that I want to show that is very useful that you might want to use in the future. It's a node called get actor data. And specifically under here under spatial, get actor data. Get actor data allows you to get the data information from either a parent blueprint or from anything in the world. Let's say you're creating a bunch of rubble and debris scattering around. You don't want it going inside of the building, so you might want to cut out that building, for example. That's what this get actor data is for. By default, actor filter self means it will find itself, which includes the parent blueprint if you have one. But you can also specify all world actors. You can specify that you want them by tag. You can find them by class. This tag, by the way, is the actor tag, not the component tag. And you can only select the first one it finds or multiple. And you can check if it overlaps itself. And if you have this on, it will only check things inside of this volume because that is itself. And more often than not, starting out at least, down here under mode, instead of parse actor components, you're just going to want to get a single point, which effectively will get the bounds of whatever it is that you're grabbing from. There are more options here, of course, but starting out, get single point will do a lot of the things you need. And if you're grabbing multiple here, the merge simple data just merges it. Now, we haven't gone over this, what is this multiple data, so let's do that. I'm going to just specify by tag, I'm going to specify the tag sphere. Of all world actors by tag, does not need to overlap itself. it can select multiple. So I'm going to just go ahead and create a simple sphere here in the world. There it is. And I'm going to search for tag. I'm going to give it the tag of the actor type sphere. And I'll put one here and maybe put one here. And I'll grab and also another one over here. So with it selected, again, I can press A like I have before, and you will see here's a point information of one of the spheres. Well, it's only one. Well, that's odd. If I press D on this node, you will see we have cubes around every single one of these. So that means it's finding all three. So why are we seeing only one? That's because in PCG, you can have points and you have multiple data of points. Think of data as an array. You can have multiple arrays, and all of the point information are the things inside of that array. So in our case, if we click here where it says PCG point array data, sphere, if I select it, you can see 0, 1, and 2. If I select them, you can see it has the different information for the positions, and I could make it all one. Now there's two ways of doing that. I could drag out of here and search for merge points, and all merge points does is take whatever is plugged into them. If I press A, it puts them all into one piece of data, and there's the three that we have. In our case, we're using the get actor data node, so it has a very nice option here to merge simple data. If I just turn that on and I press A on it, you'll see there's all three of our points. So you can see we're now getting the information from there. Also, it is getting the information based on the scale of everything. So if I go ahead and scale one of these to be 10 times bigger, you'll see it even has the 10x scale automatically grabbed. And if I press D on it, you'll see the debug cube is now encompassing the entire thing. The very final thing I want to show you guys is how to use an attribute to spawn a static mesh. We've gone over attributes, what they are, how to use them, but what if you want to now use them to spawn static meshes? Because that is a very common thing to do in PCG. In my case, I'll create a new parameter. I'll just go ahead and hit plus. I'll just double click on it to rename it. Call it static mesh. I'm going to left click on the green line here, and I'm going to search for static mesh. I'm going to change it to be a static mesh object reference. So that changes the object type here. And by default, let's go ahead and select a regular cube here, the first one. It's fine. We're going to use that. So let's say I want to spawn the cube instead now. I'm going to say detach the static mesh spawner that we had there. We're going to use a new one. We need to make use of this static mesh. So I'm going to go ahead and drag it out into the world. So there's our static mesh. And just like we did before, we're going to do the same thing like we did for kittens. I can even duplicate it over and plug it through because we want to add another attribute. I'll do it from scratch though. So I'm going to right click, search for add attribute, grab the parameter version and plug that through and plug the static mesh into the attributes. Now on this add attributes, if I didn't want to name this manually myself, I could select copy all attributes. And all this does, if I press A, is it takes that static mesh name that we had here, because that was the name of the attribute, and it just automatically populates it for us. Otherwise, we can just turn that off and name it, for example, mesh. And now on the right here, you see we have mesh. So that's cool. We have the static mesh set. So now if I drag out and grab ourselves a new static mesh spawner, how do we add a new mesh here? Because we need to use that attribute. For that, the mesh selector type, we can change from selector weighted to by attribute. Mesh selector by attribute, the very top one. And now it wants the attribute name, which we can specify was mesh, which is the one we added right before it. So I'll type in mesh, and now it is happy. And if we take a look, it is spawning cubes. And it seems like it's working. In fact, if we go ahead and select it, we can go and override the static mesh now, and I can put something else here. For example, this axis guide, and you'll see they've all now swapped out. And you can see that's the axis guide. All working. We put in cones, and we can just dynamically now swap the meshes around. You can reset it back to where it was, get the cubes back. Very cool. And just like with the blueprint actor that's spawning, you can also override the template here. With the attribute still selected, you have the template descriptor right here. You can open it up, and for example, I can set collisions to be enabled. I can change its mobility. I can change its light channels, whatever I need. It is going to use these basic settings for whatever it's spawning. Now, PCG is extremely large, so there's still a lot to go over if you want to learn everything. But hopefully this gives you the very basics of understanding now other tutorials out there, because now you understand how to debug, how to use attributes, how to spawn different things based on attributes, and much more. So hopefully this has been very helpful for you guys. Now, as always, I'll make sure to throw this project on my Patreon if you want to just play around with it for yourself, or you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join our community, the link to the Discord will be down below as always. And if you'd like to take your next step on learning PCG, check out this video right over here to continue your PCG learning journey.